You know how an app on your phone just works on your friend's phone and on your laptop, even if they're all totally different brands? We take that for granted today, right? But it wasn't always this easy. We're going to jump back to the 1990s to uncover this one revolutionary idea that basically broke software out of jail and honestly changed everything. So, to really get why this was such a huge deal, we have to start with a pretty simple question. Why was pretty much all software before 1995 stuck in what you could call a digital prison? This was the one problem that developers were absolutely desperate to solve. And this prison, well, it had a name: platform dependence. Before this big idea came along, if you wrote a program, it was basically chained to the exact computer it was built for. So if it was born on a Windows machine, it was going to die on a Windows machine. You couldn't just, pick it up and move it over to a Mac or a Unix system. No way. Now, leading up to 1995, we had these really powerful languages like C and C++. They were great, but they all had that same fatal flaw. They built programs with these invisible walls around them. And then, in 95, Java shows up, and it arrives with this incredible promise to set all of that software free. Just so we're all on the same page, when we say platform, it's not just the operating system like Windows or Mac OS. It's really the combo of the OS and the hardware, specifically the computer's brain, the microprocessor. Every machine has this unique pair, and that pairing was basically the warden of our little software prison. Okay, so here's how things used to work with a language like C++. A developer writes their code, which is kind of like a set of blueprints. Then they feed those blueprints into a tool called a compiler. The compiler's job is to translate the blueprints into instructions the computer can actually follow. But, and this is the big but, it translated it into a very specific dialect that only the Windows microprocessor could understand. And right here is where you can actually see the prison walls. You take that program, the one made for Windows, and run it on a Windows PC. Works like a charm. But then you take that exact same file, move it over to a Unix machine, and it just flat out fails. The Unix chip looks at those instructions and it's just complete gibberish to it. This really just perfectly sums up how frustrating this was for developers. I mean, imagine spending months building something amazing, only to realize that it's locked out of, maybe 75% of its potential users because they're on different computers. It was a huge roadblock, both technically and for business. But then, in 1995, everything changed. This new language, Java, burst onto the scene, and it came with this incredibly bold promise that took a direct shot at this whole one-platform prison problem. And this was it. This was the slogan, the dream, the holy grail for every developer on the planet. Write once, run anywhere. The idea itself sounds so simple, but it was massive. You should only have to write your code one time, and it should just work everywhere. Any computer, any platform, no questions asked. The thing is, how on earth was that even possible? Well, the secret sauce, the magic behind that promise, really boiled down to two brand new ideas that work together perfectly. Something called bytecode and the Java virtual machine, or what everyone calls the JVM. These two things were the key that unlocked the prison door. Okay, so remember how that C++ compiler made a file that only one type of machine could understand? Well, the Java compiler did something totally different. Instead of spitting out platform-specific machine code, it created a brand new type of file, a universal, one-size-fits-all file called bytecode. So what in the world is bytecode? The best way to think of it is like a universal language. It's not English for us, and it's not the specific dialect for a Windows or a Mac machine. It's this perfectly neutral, in-between language. It's a portable file that can travel anywhere, but it needs one more piece to actually do anything. And that final piece of the puzzle is the Java virtual machine, the JVM. The JVM is this special little translator program you install on your computer. And here's the genius part. There's a different JVM for Windows, a different one for Mac, a different one for Unix, and its only job, its entire purpose, is to take that universal bytecode and do that final on-the-spot translation into the native language that your specific computer understands. So let's walk through this new, much better process. A developer writes their Java code just one time. The compiler turns it into that universal bytecode. Then you can email, download, or send that single bytecode file to any computer you want. The JVM on that local machine, doesn't matter if it's Windows, Mac, or Unix, it handles that last step of translation. And just like that, the program runs perfectly, everywhere. Honestly, if you remember just one thing from all of this, let it be this. The Java code itself is platform independent. It can go anywhere. But the JVM, that little translator, is platform dependent. You need the right translator for the right machine. And that clever separation of jobs is what makes the whole thing work. So, what did this actually mean in the real world? Well, write once, run anywhere wasn't just some cool tech slogan. It completely flipped the entire business of software on its head. I mean, just think about the business side of it for a second. Before Java, maybe your incredible C++ app could only reach, say, 25% of the market. Just the Windows people. The other 75%? Sorry, they're locked out. But with Java, you write that app once and boom, your potential market is now 100%. Everybody with a computer could be your customer. It was an absolute game changer.
And this powerful idea of freedom goes by a lot of different names. You might hear people call it platform independence, or the famous acronym WARA, or portability, or the super technical term architecture neutral. But they're all just different ways of saying the exact same thing, making one program that can truly live anywhere and everywhere. When you get right down to it, this simple but absolutely brilliant idea from the 90s is what built the foundation for the internet, for mobile apps, for this entire connected digital world that we all live in today. It tore down the walls between our computers. So it kind of leaves you with one big question. What's the